A variable's default value is the value that the variable gets if there's no explicit initialization. So in the mouse class, we have an example of both explicit initializations and variables that receive a default value. Okay. It's important to realize this fact. By default, integers are set to 0, floating point values are set to 0.0, Boolean variables are false, and reference types are set to null. Okay? And since strings are a reference type, then it would be you'd be right to assume that they are set to null as well. And just for an aside, if you didn't know, null comes from the Latin words ni, which is equal to not, and ullus, which equals any. And so they make the single word nullus, and then the French later shortened it to just null. So just some gee whiz for you, but if you combine the Latin words, it's not any. So basically, a reference type gets set to not any, or nothing. When we talk about persistence, we're talking about how long a variable exists. And the book talks about how instance variables persist for the duration of a particular object. And if an object makes two method calls, the second called method does not reset the calling object's instant variables to their initialized value. Instead, the object's instance variables retain their values from one method call to the next. So say we have an object A, and inside of it we have a private integer variable x that has been initialized to 10. And we call a method that modifies the value of x. Say add 2 to x, right? It's going to do what it says. It's going to add 2 to x. And it will persist for the life of the object, which is the case object A. So as long as object A is around, this private variable x will be around. And if we call this method again, add 2 to x a second time, well, now our value will be incremented by another 2. So it's going to be equal to 14. The state of x did not change between this call and this call, right? Once it's initialized to 10, that's it until it changes, in which case this method call changed it to 12, and then this one added it, added another one, which made it 14. Okay? They're both getting access to the same current information or state of object A. So now that we've gone through all that, we can expand our discussion of UML class diagrams with a little bit of additional information. So let's go ahead and take a look at a new mouse class called mouse2. And first, we can specify initial values on our class diagram by showing the initialization value, right? So you can see right here we have our age variable, which is an integer, and we set it equal to 0. And we can also show member accessibility by using pluses and minuses. So you can see here that minuses are private variables, so these are not available to anybody outside of the mouse class, but pluses are accessible to anybody outside of the mouse class, and so we can use these methods to control how we get this information, right? So we are saying we're going to create a method called getAge, which is going to return this variable. And so we are controlling how somebody can access the data within our mouse2 class. And finally, we can include additional information that may not be tied directly to the class with method notes. And you're going to see these as little, folded corner pages right here. And it's important that you learn how to read this documentation because it's also useful when you're thinking about your class. And it's much easier to write down their methods and attributes during the design phase than to just build the whole program from scratch with no idea of what direction you're heading. And this is really, it gets into play when you're dealing with lots of different classes. When you're building an application, you might have hundreds or even thousands of classes to make your application work. And if you just keep building it and building it and building it, you're going to get this what we call spaghetti code, where everything's connected together and nothing is cohesive. So really, you want to think about your in general terms how you're going to build your class or build your application, and start fleshing out some of the details on how these things are going to interact. And UML is a great tool to help you do that. As we saw in the UML diagram for mouse 2, we talked about local variables. Well, a local variable is a variable that's declared inside of a method. And that's different from an instance variable, which is declared at the top of a class outside of all the methods. A local variable is called local because it can only be used inside of the method in which it was declared. It's completely local to that method. If we were to take a look at the mouse2 driver class, note how the main method has 3 local variables: standard in, Mickey, and days. These variables will only exist as long as the method that created them is still on the call stack. Once we exit the method, the variable's memory will be released, and the Java garbage collector process will return the memory to the host operating system. So naturally, if we have a main program, usually once we fully exit the main method, the program is going to be terminated. But a lot of times we might have other methods that aren't critical to the main control of the program. So if this was like, say, some kind of print method, and these variables were created inside that print method, as soon as that print method was done, these variables would go away.